This video is continuing from last video from multiple choice questions unit 1 exam. And this is a free response, okay? Number 1, quinine is a pharmaceutical a drug that was the first Western medicine that could effectively treat malaria. It also is a flammable hydrocarbon that contains carbon, hydrogen, nitrogen, and oxygen. When 0.487 grams of quinine, molar mass is 324 gram per mole, that's molar mass, is combusted, so combined with the oxygen. It is found to produce 1.321 kilogram of CO2, 0.235 gram of H2O, 0.0421 gram of nitrogen. Okay, so you have a 3 product. Now, determine the mass of carbon and hydrogen that are present in quinine. Okay. So what you need to start from here is that they gave you this quinine, that much it combusted. Okay. So you can start from 0.487 gram of quinine. We don't know that chemical equation yet. So that one, just leave it there. Now, what is a mass of carbon, right? Mass of carbon. So where's the carbon? Carbon is in the product side you have there. So what you can do is CO2, right? CO2, what is a molar mass of CO2? It doesn't give it to you. So you can calculate C is a 12.01 plus 2 times a 16, right? So then when you compute, that's approximately, so around the 44, okay? I'm gonna just round up nearly to unit digit. So you can say, actually, so you can start from that only C, right? Carbon is from CO2. So you can say in here, 1 mole of CO2, which is a 44 gram, right? And then C is basically 12. Okay. So then, if it's a 1.321 gram, then how much, right? Then you can find out X value. So when you compute 12 times 1.321 and divide by 44, I got 0.36 gram of C, carbon. Okay, that's your answer. Now, what about hydrogen? Hydrogen only in here. So hydrogen, that's H2O is about 18. And you have 2 hydrogen, right? Then 2 times 1 is a 2. So that's a ratio of hydrogen in H2O. So that's a 0.325 gram, and then how much, right? Then you can find out your X value too. So 2 times 0.325 divided by 18, that gives me 0.0361 gram of your H, hydrogen. Okay, that's the answer. That's the mass of carbon and mass of hydrogen are present in quinine. Now, determine the mass of the oxygen that are present in quinine. So what you can do is oxygen, it belongs to these 2 elements, right? There's 2 molecules, and there's a. So one way you can do is you can starting from the 0.487 gram of quinine. So if you subtract mass for carbon, which is 0.36, and then mass for hydrogen, 0.0361, right? And minus also mass of the nitrogen, 0.0421. So that gives me mass of oxygen, right? So you can find out mass of oxygen. So 0.487 minus 0.36 minus 0.0361 minus 0.0421. I guess I got 4.0488 gram of O. So that's a mass of oxygen in that quinine. Now determine empirical formula. So how can I find out empirical formula? So you find out molar ratio, each one, mole. So let's say C, right? C, we got this one, 0.36. So you start from 0.36 gram of C. And 1 mole of C is basically 12 gram of C. So then you can find out more, right? So when you use calculator, so I got 0.0300 more, okay, of C. Now similarly, you can do for H. H, we got this one here, so 0.0361 gram of H, and then 1 mole of H is 1 gram, right? So then 0.0361 mole of H. Okay. What about oxygen? Oxygen. So similarly, you can start from oxygen right here. So 0.0488 gram of oxygen, and then 1 mole of oxygen is 16. So when you multiply it out, you get 0.00303 mole of oxygen. And last one, nitrogen. Nitrogen, you get, they said 0.0421 gram of nitrogen, and 1 mole of nitrogen is, if you look at the periodic table, that's a 14 gram of nitrogen. So then you get 0.00300 around. So 10 mole of nitrogen. So you divide by empirical formula. What you have to do is each mole you divide by all of them into small one. So this is about the same. Okay, so that's about the same. So I'm gonna divide by 0.003, right? Around. So then let's see what do you get. So this one 1 and 0.0361 divided by 0.003, you get about 12. And the other one 0.03 divided by 0.003, so you get 10. Okay, so I can set up now empirical formula. So C10, H12, and O1 and N1. Okay, that's your empirical formula. Or ON, you don't have to put 1, just ON. Now determine molecular formula. So there's a difference. Molecular formula, empirical formula, and molecular formula. A molecular formula is actual formula, right? Empirical formula, this is not actual one because that's based on the gram we found. Now, they gave you molar mass right here. So let's find out molar mass of this empirical formula. So which is 12 times 10 plus, C is 12. So 1 times 12 plus 1 times 16 plus 1 times 14. Right? So let's calculate. So 120 plus 12 plus 16 plus 14. I got 162. Okay? So this one 162, 162 gram is that empirical formula molar mass. Now this one is that's exactly 2, right? So 324 divided by 162 will give you 2. So what you have to do is molecular formula is twice of that empirical formula. So twice of C 10H12 O1N1. So your final molecular formula is then C20 H24 O2N2. Okay, that's your molecular formula. Actual one, I think that they should switch it, but it wouldn't matter. Okay. Now, a method of spectrometry plot was obtained for elemental carbon and for the carbon contained quinine. And based on the plots found below, discuss the differences in terms of composition of carbon. The differences in terms of composition of carbon between sample of element carbon compared to sample of quinine. Okay, so if you look at those two spectrometry, this is about carbon, right? Carbon math. Now, so you see that there's about 12, yeah, about that, and 13 very small, right? So basically, you have only two kinds. So this shows two isotope. Okay, and then so it has right here. It has greater percent of math on 12, right? So that's why it's a C is a math. If you look at it, 12.01, right? So that shows, right? What about here? I see that 3 bar, so that means a 3 isotope. Okay, so 3 isotope present, and then of course this one also C is a 12. So this in quinine, your carbon math is a little bigger than actual one 12.01. It should be like a little bigger than that. Okay, so it depends on like your percent. But anyway, this one shows a 2 isotope, and the other one is that spectrum shows a 3 isotope of the carbon. Okay, that's the difference. Next one, number 2. Copper metal is obtained from copper ore, and one common form of the copper ore is malachite, and CuCO3 CO2 2 OH2. And when isolating copper from malachite, the ore is run through a series of chemical reactions, decomposition and single replacement, as shown below. Okay, so this one we call decomposition, and this one is a single replacement. Okay. Now, 1.82 gram of piece of malachite is used by a chemist for one trial of experiment. How many grams of copper to oxide? Copper to oxide means that this is CuO. Because the reason why Cu this one second is oxide is a 2 minus charge, Cu is a 2 plus charge. So that charge is A. Okay, that's why it's the second. Oxide should theoretically be retrieved after decomposition reaction. Okay, so how many this one comes out in here? So you can start from 1.82 gram of this, right? The malachite, which is a CuCO3 CuOH2. Okay, you start from that. Now, so one more of that malachite. So this one, if you calculate the molar math using that periodic table, you should get around 221.116 gram. I already computed. So times, now if you look at the molar ratios, this one malachite, you get 2 mole of copper oxide, right? So 1 malachite you're gonna have 2 CuO. Okay. Then they ask how many grams actually. So I mean this is mole. So 1 mole of CuO, molar mass for CuO when you use a periodic table, that's a 79.545 gram. Okay, and then now if you multiply, you see that this gram, this malachite gram, it cancels, and malachite mole cancel, and this mole of CuO cancel, and then you have only gram of CuO, right? So your final answer, if you compute this one, use calculator, then around 1.31 gram of copper 2 oxide. That's your final answer. Okay. Let's move on. B, after single replacement, they talk about step 2, completed. Determine the percentage of original 1.82 gram malachite sample that is comprised of copper. What is the percent of copper? So I'm gonna start from the one we found in A. So 1.31 gram of CuO. Okay, so in here. Times, you change into mole. So molar mass is 1 mole of CuO is, we already found there, 79.545 gram of CuO. Copper is right here. So 2 mole of CuO, 2 mole of Cu, right? And then you're looking for how many grams first. So 1 mole of Cu is, when you look at the periodic table, 63.546 gram of Cu. Then you can find out how many gram of Cu it comes out, right? So when you multiply it out, you get 1.05 gram of Cu. Okay. Now your final answer should be, is that percentage of original this gram malachite sample that is composed of copper. So copper, 1.05 gram of copper out of your malachite was a 1.82 gram, right? 1.82 gram of malachite, right? Times 100. That's a percent mass of copper in malachite. So then when you calculate, that's a 57.7%. Okay, that's your final answer. So what I did is starting from here, and then using molar mass and then molar ratio of Cu and CuO, you can find out, using also molar mass of copper, you can find out how many grams of copper is there. In here, 1.82 gram of malachite. So this one, what is the percent math of here? Okay, so that divided by this times 100 will give you 57.7% copper exists in that 1 mole of malachite. Now C, in order to check for the purity of ore, a simple experiment using copper sample in a different trial was done using water displacement. The following data was retrieved and used for analysis. Okay, so they try 4 samples right here, copper. Okay, and what they give you later on is the density of each one. But we are looking for a copper sample, so we use only this one here, copper sample density. So the way you have to do is that here on the problem here, based on the data and reference values, discuss the purity of copper obtained from ore. Explain your response. So I need to find out then density and then compare with that standard value. So how much pure that copper is. Okay. So then what you have to do is, what is the copper density? Density is mass over volume, right? So mass over volume. So mass copper is this one, and then volume. There's initial cylinder here, and then cylinder with the copper is there. So their difference, this minus this. So there 4.5 milliliter it occupy, right? So after you put that copper in the cylinder, that much increase. So that shows that is a volume of copper. So your density for this one is a 33 gram over divided by 4.5 milliliter, right? So that one, if you use a calculator, 33 divided by 4.5, I got around 7.33. Okay, so if you keep going, so also this one is you subtract, so 7.6 milliliter, so 7 point the 55 math, so you have to do 54 math, 54 divided by 7.6, so I got 7.11 around. Next one 7.11, I'm talking about density. And if you do the next one, you get this one is a 7.18 and next one is a 6.91. Okay. Now compared to this actual density right here, the actual density is way higher. Okay, so those are not enough density to the actual one. So I can say in those ore, right? The ore is not pure copper. So you can say none of them, right? None of them are close to pure copper, because their density is a lot smaller than the actual pure density of copper. Okay, that should be fine answer. Now number 3, elemental sulfur can be obtained through the closed process. One of the steps in the process involves the reaction between sulfur dioxide and hydrogen sulfide. The stoichiometry reaction is provided below. Okay, they gave you this chemical equation for you. Okay, now so A, draw molecular picture upon the reaction going to completion based on the molecular picture provided for the reaction as shown below. So, okay, you have to recognize which one is which. What is SO2? This is sulfur S and O is oxygen, that gray one, and the smaller one is hydrogen, right? So you can say that's H2S, and then the other one is SO2, right? So SO2. So this one, I think is they need to highlight here. So I think it kind of should be this way. It should be highlighted. Okay. So then that is a SO2, right? This is SO2, like that. So the molar ratio is a 1 to 2. So SO2 unit 1, but as you see, it's a limiting reactant is SO2. So because you have only 2 here, but H2SO you have a bunch. So for 1 you need 2, but this one is you have a 1, 2. 2 SO2, then you're gonna have 4 H2S. So you have 1, 2, 3, 4. 4 you're gonna need. So what you have to do is draw molecular picture on the completion, right? So then you can draw. First of all, that little one, I'm gonna just put it like that. I need to draw 4 of them, right? like that, and then that gray one, two of them, right? Like this. Hold on, wait a second. Oh, no, no, no. I take it back. This one is a product. So product side, you need to draw this one. So you need to draw 6s, because basically twice of that, right? Entire equation you have to multiply it 2. So 6s and then 4H2O. So you need to draw this on product side after completion. So 6s, so 1, 2, 3, 4, 5, 6. Those are 6 sulfurs. Now H2O, O is that gray one, right? H is this, like that. So you need to have this on H2O. You have 4 of them. Three and 4. Okay, those are water, H2O, and this on sulfur. And then you have to draw this on 2 leftover. This one is still in the product side. It's unreacted, right? So I'm gonna draw like that, right? So that's a H2S. So that's it. That's your product side. Okay. Have to draw. Identify the limiting reactant. So we already talked about limiting reactant. It should be H2, SO2, right? SO2, right? Justify, because SO2 molecules consumed completely, right? In reaction. But H2S, right, remain in product side. Okay, so that will tell you. Now, next one, C. So after reaction has gone to completion, 8 more molecules of hydrogen sulfide, which is H2S, are added. Okay, in the reaction vessel. Then discuss how the yield of the sulfur is influenced. Nothing will happen, because you see that in the product side here. So this one is unreacted, right? Because there's no more SO2. So even if you more H2S, so you add it, nothing will happen. So you have to say no effect. Okay. So you can say, just explain, because adding more H2S won't, right? Won't affect the product, the more product. Okay, so it won't happen anything. All right, that's it for this video.